Okay, Namaskar and good evening, all of you. Welcome to yet another session on Class 10 CBSE revision. Today, we are going to deal with this chapter called Carbon and its Compounds. Okay, now, what is carbon? Basically, any of you just unmute yourselves.
Carbon is an element.
Carbon is an element. Yes. Yes, Samvardhika, you were saying something. Please go ahead.
It is a non-metal.
It is a non-metal. Wonderful. Thank you, Anisha and Samvardhika. So carbon is basically an element. Okay. And it is, what is the position in the periodic table? Kirtana, can you say what is the position of carbon in the periodic table?
Yes, ma'am. Can you repeat the question, ma'am?
Yeah. What is the position of carbon in periodic table? Which period does it come in?
Second period, ma'am.
Yes, very good. It comes in the second period. Okay. So it is her, he is the first period. Hydrogen, helium. Then second period is libepsin of neon. Libebcnof, neon. Libepsin of neon. And so it comes in the second period. All right. Samanya, can you tell me what is the atomic number of carbon?
6.
Yes, it is 6. The atomic number of carbon is 6. So, Yashni, what is the electronic configuration of carbon?
2,4, ma'am.
2,4. Thank you. Vishal, what will be the valency of carbon?
4, ma'am.
4. Yes, thank you so much. All right. Now, tell me something. Have all of you seen carbon? Give me a thumbs up or thumbs down. Have you all seen carbon? Yes? No? No? Ayyo Rama. Have you seen Kajal? The eyeliner thing, which your moms put, which you all put? That is carbon. Okay. Have you ever seen paper being burnt? Or have you all tried burning papers? Yes. No? Okay. So after burning paper, what happens? Once the paper is burnt, what is there that gets left behind? How does
Black
it look?
residue, ma'am.
Yes, it's a black residue, right? That black residue is nothing but carbon. Okay. You all have seen coal, C-O-A-L, coal?
Yes.
Somewhere in the films or something, somewhere you must have seen, no? That is also black, right? Why is it black? Because it is carbon. Okay. So carbon is nothing but all that black color thing that gets left behind after being burnt. That, and why is it that that black color thing gets left behind? Because it is an organic compound. Okay. Anything that contains carbon upon burning leaves behind a black color residue. For that matter, even diamond, if you take and you burn it, don't actually try it. Your mothers will come and hit me. But it will get left behind as a black colored residue, which is carbon. All right. That is in the simplest terms I can tell you. All right. So all of you have seen carbon, right? Yeah. Today, my daughter gave me a very funny reply. She asked me, which chapter is there today for Vidyadan? And I told her carbon and its compounds. So she was like, oh, that is a thing which is present in air and which we keep breathing out. I said, please don't give me such heart attacks. Talk to me something with a little more logical. So carbon is, but one thing is carbon is present in the air in the form of carbon dioxide, which is a gas, right? Okay. Now, please don't come and ask me, ma'am, our hair is all black. Does that mean it is carbon? Is it carbon? What is it? Vishal, Vishal is like, what is it then? It is a protein. Okay. Our hair and our nails contain a protein called as keratin, which is an insoluble protein. It cannot dissolve in water. Okay, both our hair and nails. That's why if the hair goes inside our mouth, we feel very funny, right? It's like something happening, right? But if milk is going in our mouth, we don't feel really very funny, do we? Milk, or for that matter, sprouted beans and all that. They are also proteins. But hair and nails are fibrous proteins. They contain a lot of fiber. Okay. Sorry. All right. Enough of proteins and all. Let's come back to carbon. Now, so carbon is an element that is in the second period of the periodic table. And anything containing carbon is called as an organic compound. Okay. It is called organic compound. In higher classes, you will learn something called as organic chemistry. In fact, the thing that we are dealing with today is the first introduction of organic chemistry. Okay. And you use a lot of organic chemistry in your houses. You can find it out later. Okay. All right. Now, coming back to carbon. Can you tell me what is the speciality of carbon? I mean, I'm sure you all have done this chapter a lot of times. So rather than me yapping, you all talk. What is so special about carbon? Samanya?
Yes.
Yeah. I beg your pardon? Okay, I think I lost you there, Samanya. All right. Yashni, can you tell me what is so special about carbon that you have learned?
It shares a covalent bond, ma'am.
Okay. What is the meaning of covalent bond?
Mutual sharing of atoms is said to be covalent bond.
Okay. Why do you think it is mutual sharing of atoms? Samvardhika.
It possesses the property of tetravalency.
Tetravalency. Okay. Why does it have tetravalency? Vishal, can you try?
Yes, ma'am, because it is in the 14th group.
Okay. All right. Something a little more precise?
So,
Anish,
and it has
yeah.
4 has valency. Ma'am. Am I
All
right?
right. Tetravalency mane 4 na? Okay. So here it is. Thank you so much for all the answers. Now, this is the, I hope you all can see my whiteboard. Just change the color. Okay. So now carbon, the atomic number. Here, Rama, what is this color? Yeah. Sorry, Carbon has atomic number 6. Please give me 1 minute. So that means the electron configuration is 2, 4. I don't know, for some reason this has become too thick. I'm just trying to change the size, but it's not becoming possible. Okay. But this is clear enough, whatever I'm writing on the board. Is it clear? Okay.
Yes,
so 2, 4 is the electron configuration. That means how many electrons are there in the outermost shell? There are 4 electrons.
4.
Yes. Now, Anisha, can you tell me how many electrons are needed for any atom to become stable? In the outermost shell, how many electrons should be there?
8 electrons, ma'am.
8 electrons, correct. Now, so It is already having 4. How many more electrons should it take, Kirtana?
4, ma'am.
Another 4 electrons. Now, what is easier for it? Now, there are 2 things that is possible. Okay. One, either it can give away the 4 electrons and become positive. C plus 4. Okay. C plus 4 means it is cation or anion?
Cation.
Yes. And or it can take 4 electrons and become C minus 4. All right. But what will happen? Giving away 4 electron, it becomes very difficult. Okay. Because then the entire balancing of the atom goes haywire. And taking 4 electrons, will there be any element that is ready to give away all the 4 electrons? It is like this. Like you need, or I need 40,000 rupees. Okay. I go and ask Samanya, give me 40,000 rupees. But she cannot give me complete 40,000 rupees. Okay. So I will ask her, okay, what is it that you can give me? She'll say 10,000. I say, okay, no problem. You give me 10,000. I ask another 10,000 from Anisha. I ask another 10,000 from Kirtana. And another 10,000 from maybe Samvardhika. So like that I will do, right? Taking from all different elements. Now here in this case, in case of carbon, that is also a little difficult. Okay, taking from 4 different elements. Borrowing, 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 borrowing. So what does it do? A simpler way is it is going to look around for which is the atom or which is the element that does not have a full complete octet. Okay. So the easiest element in that case is hydrogen. Why? Because what is the atomic number of hydrogen, Vishal?
2, ma'am.
Pardon?
What is your question?
What is the atomic number of hydrogen?
1, ma'am.
1. So how many electrons does it have, Anisha?
1, ma'am.
Only 1 electron, and that too in the K shell. Okay. So what is happening? If it is in the K shell, then in K shell, it has on maximum, it can accommodate only 2 electrons. Okay. So what is easy for carbon? Carbon will say, you come here. I will share one of my electron with you. You share your 1 electron with me. You get 2 electrons to become stable. I also get 1 more electron so that I am also nearing the stability. And then what does this hydrogen do? Hydrogen says, okay, you don't worry. You need 4 electrons. Now, I will bring 3 more of my friends. Okay. So then together, what will they do? They all will make a bond and all of them will start sharing their electrons. Okay. Cross, dot, cross, dot, cross, dot, cross and dot. Okay. So here what is going to happen? These 2 are sharing the electrons. This one is sharing, this one is sharing, and this one is also sharing. So this way, carbon is also completing the octet. Hydrogen is also becoming stable. All right. This thing of this tendency of carbon to bond with 4 other atoms, we call it as tetravalency. Okay. This much, is it okay with you? Or did I speak too much? All right. Do you have any doubts over here? Samvardhika, Samanya, Yashni? All okay?
No doubts, ma'am.
Okay, fine. All right. Now we will go to the next part. Now this tetravalency is done. Now the next part is about, what is it? What is another specialty of carbon? Anybody?
Catenation, ma'am.
Property of
Catenation.
Catenation. Now what is catenation?
Formation of
Ability
long
of
chains, ma'am.
carbon to form long chains is called as catenation.
Yes. Thank you, Vishal. Thank you, Samvardhika. Do you all like jewelry? No? Anisha is like, So, now what does carbon do? Carbon can bond with any other element, any other atom. Okay. And it can keep on forming big chain. And this tendency to make chain is called as catenation. All right. So that's why I asked, do you all like jewelry? When I was small, I used to keep threading the pearls and make small male, vale, and all that. So, so this is something like that. Okay, that thread which we use to make that necklace or to make the chain, whatever, that is your bond. Okay, and the pearls which we keep stringing together, that is your carbon atom. Okay, now carbon has this beautiful property of catenation. Can anybody tell me why is it having this tendency of catenation? Anybody, just unmute yourselves.
Because of covalent bonding.
Because of the covalent bonding. Okay, what else? So it keeps forming bonds with other atoms of carbon. Now, carbon does not share just with hydrogen alone. Okay. It can share with other atoms of carbon also to attain the stability. And when these carbon, they keep bonding and forming long chains. Sometimes they also form branch chains. And sometimes they form rings also. Like one example of benzene. Okay, have you heard of this benzene ring? What is benzene? Okay, benzene is an organic compound and it has a something like a phenyl kind of smell. Okay, the phenyl kind of smell that we get is sometimes from the benzene ring. Okay, now benzene has got a ring-like structure. Okay, so carbon, it keeps forming bonds. Sometimes it forms chains. Sometimes it makes branched structure. Sometimes it becomes a ring. Okay, now this is a versatility of carbon. It is like, anyway, you can form bonds with me. I can make 3D structure. I can make long chain also. I can make rings also. You tell me what do you want. I will make rings, but you should fulfill my valency. That is what carbon keeps telling. Okay. So what is one beautiful thing about carbon is, it is very easy to make all sorts of bonds with carbon. Okay, I'll just erase this. It is very easy to make all sorts of bond with carbon. I will show you the main simplest bond, that is single bond. Okay, you keep making these kind of bonds. Now, carbon is tetravalent in nature, right? That means it has to bond with 3 other atoms. Those 3 other atoms can be either other carbon atom or other hydrogen atom. So, for example, if we are having hydrogen atom, then it will become 1, 2, 3. Then again 1 and 2. 1 and 2. 1, 2, and 3. Okay. So how is it that you keep checking for the carbon structure, whether it is fulfilled or no? You always ensure that it has got 4 bonds. Okay, that is tip number 1. Okay. Now, let us go to other parts, something a little more in detail. Okay. Have you heard of saturated and unsaturated carbons? That is a type of carbon compounds. What are they, Anisha? Unmute. Unmute. Okay, no problem, Anisha. All right, in that case, Yashni, can you tell me what is saturated and unsaturated carbon?
Ma'am, when carbon shares a single bond, it is saturated carbons, and when it shares double or triple bond, then it's unsaturated carbon.
Why does it have double or triple bond?
Because it shares atoms with other elements, ma'am, like other than hydrogen, like oxygen.
There is carbon-carbon double bond also, no?
Yes.
Why does it form a double bond? To fulfill the valency. Everywhere, always remember this one thing. In chemistry, when elements in chemistry, not just organic, in any kind of chemistry, elements, when they are forming bonds, they form bond to fulfill the valency and become a stable structure. Okay. So here also, there are 2 types of carbon atoms. One is saturated, as Yashni said. They have single bond. And the other is unsaturated, which has a double bond or a triple bond. Okay. Now let us look at the types of carbon atom. Now there are 3 types of carbon atom. Now I will teach you the way my sir, Sham sir, the way he taught me, my organic chemistry professor, the way he had taught me, I'll teach you the same way. Okay. So this is how he did. 1. What comes after 1? Kirtana, which is the next number?
2.
2. Samanya, which is the next number after 2?
3.
3. Okay. 1, 2, 3. This is 1. That means it has carbon-carbon single bond. This is 2. It means there is carbon-carbon double bond. This is 3. So it has carbon-carbon. How many bonds? Triple bond.
Triple bond.
Yes. Now this carbon-carbon single bond is called alkane. Double bond is called alkene. And triple bond is called alkyne. That is A, E, and Y. Okay. Alkane, alkene, alkyne. 1, 2, 3. Simple to remember. Then this one bond is all saturated. 2 and 3, these 2 are unsaturated. Okay? Is this much okay? Always remember 1, 2, 3. Single, double, triple. Alkane, alkene, alkyne. Okay. Ane, ene, ine. Okay? This much, is it okay? Now, let us go to the next part. That is methane, ethane, propane, butane. Okay. Always remember it like this. Meth or methane, ethane, propane, butane. Meth, eth, prop, but. 1, 2, 3, 4. Okay. This is 1. 1 is methane. 1 is methane. That means how many carbon atoms will be there? Samanya, can you tell me?
One more.
Only 1 carbon atom. Okay. Now, Yashni, can you tell me in ethane, how many carbon atoms will be there?
2, ma'am.
2 carbon atoms. Propane, if you look, it is 3, that is 3 carbon atoms, and butane is 4. Meth, eth, prop, but, 1, 2, 3, 4. Okay. So once you remember this much, then the rest of the things are easy because you have pentane, hexane, septane, and all that. That too you already know. Pentane, pent means 5. Hexane, hexagon. Hexagon has 6 sides. So hex means 6. For 7, you say sept. So septane, which is 7. Then octane, which is 8. Okay, the other things are very easy. But these first 4 compounds is where generally people get confused. Okay, so that is the reason I just thought of throwing focus on this. Methane, ethane, propane, butane. Meth, eth, prop, but. 1, 2, 3, 4. Okay. So then, can we have an alkene with just 1 single carbon atom? Can we have an alkene with 1 single carbon atom? Yes, no? Arey. Yes or no? No. Why do you think so, Vishal?
I don't really have an exact answer for that one, so I just.
It is very simple. See, it has to have alkene needs a double bond. It has to have a carbon-carbon double bond. Hai na? Now, carbon hydrogen, you cannot have double bond because bichara hydrogen already has only 1 electron. It is also sharing that 1 electron with carbon. Right? So you cannot have, for methane, you cannot have alkene and alkyne. Okay, there is no carbon-carbon double or triple bond in case of methane because it is only 1 carbon atom. Okay, you have unsaturated carbon atoms beginning from ethane. You need to have minimum 2 carbon atoms to have an unsaturated carbon atom. That is why we have ethene and ethyne. Alkene is ethene, alkyne is ethyne. Alkyne is ethyne. That means how many bonds between the carbon atoms? Kirtana.
Triple bond.
Very good. It is triple bond. Okay? This much, is it okay with you? Are you all clear with this? Yes or no? Yellame korinju pongal aicha. Is it all pongal in your head? No, na? If it's pongal, just tell me. We can try to separate the lentils and rice. Okay, so moving on to the next part is about the homologous series. Have you heard of this homologous series? Yes, no?
Yes, ma'am.
Yes,
Okay,
ma'am.
so what is it? Any one of you, just unmute yourself.
A series which has CH2 difference, ma'am.
A series that has CH2 difference. Okay, Samanya, can you give me an example for that?
Alkane chains, ma'am, like methane, ethane, in all different wise bonds yet.
Yes, right. If you look at all the carbon atoms, all the organic compounds, you can just write it down. Okay. Methane, ethane, propane, butane, pentane, hexane, septane, octane, nonane, decane. if you write them down, write the entire structure, okay, then you will see between methane and ethane, there's a difference of CH2. Between ethane and propane, there's a difference of CH2. Same case for propane and butane, butane and pentane, like that. You can actually write it down and see. Okay. And it is very interesting to note. And this particular, I'll just show you, I'll write down for the first four. See, methane is CH4, correct? Sorry, I really don't know why the nib thickness is so much. Then ethane has how many carbon atoms, Vishal?
Ethane has 2 more.
2. C, single bond C. And then you go on putting H, H, H1. Then 2, 3, and 4. So that is ethane. Then is propane. 3 carbon atoms. 1, 2, 3. Then 1, 2, 3, 4. 1, 2. This 1, 2 I'm counting as a number of bonds. Okay. 1, 2. So 3 and 4. Similarly, 1, 2, 3, and 4. So this, if you see everywhere, it is 4, 4. Why I kept counting this? Because later in your, if by any chance in your 11th and 12th, you take up science and you take up chemistry, then making these big organic compound is going to be very difficult if you haven't learned how to make the bonds. That is the reason. And this is the easiest way. Even Shamsa taught me by this way. And it has worked for me all these years. I have survived these many years with this. Okay. And this is one of the easiest ways for you to calculate the bonds. Now, if you look, this is what? Propane. If you look, there is, here there are 2 carbon atoms, each having 3 hydrogen bonds in case of ethane, right? So here what did we do? We just made a small space in between the 2 carbon atoms of ethane and we added one CH2. Okay. Similarly, over here, if you look at methane, it is CH4. Okay. Then what did we do? We removed one hydrogen from this methane. After removing this one hydrogen from methane, what did we do? We added one more carbon atom and then we put 3 more hydrogen atoms. So it became, methane became ethane. Did you understand? So this difference of CH2 group, it is called as homologous series or homology. Okay. Now, this is one very important characteristic of organic compounds, because it is depending on this that we have a lot of other chemical reactions and everything. All right. Okay. Till here, any doubt? Or life is beautiful? Life is beautiful? Okay. All right. So now we will go to some questions. Okay. By any chance, I hope you don't have functional groups. Huh? Do you have functional groups? That is alcohol. Yes, you have? Okay, great. That's one of my favorite parts. Then in that case, you tell me, what is a functional group? What is the meaning of functional group?
That can be put in plates instead of hydrogen with carbon atom.
Yes. Okay, fine. Now, in very simple layman terms, I'll tell you. We all have different names, no? Indira VMD, Samvardhika RJ, Vishal M, Kirtana Parthiban, Like that, we have different names, right? One is a main name. One is our first name or the name by which everybody calls you, right? Then there is a last name or a surname or initials, right? Like VMD or M or CM, RJ, Parthiban, like that, right? Now that surname which we all have, that is something analogous to the functional group. Okay. All right. Basically, all of us are what? We all are humans, right? But as humans, we have different families. We come from different families. That's the same thing with these organic compounds. All these organic compounds belong to different families. Like something is an alcohol family, some of them are halogen family, some of them are aldehyde family, ketone family, like that. So depending on the family, they have a surname attached to them. Purinjada. That is the reason of functional group. Okay, or that is the main funda of functional group. Just think of it like that. And that's how I have understood it also. Okay. Now, there are some functional groups which you will be learning in your 10th standard. And I'm sure some of you might be a bit confused about it. And let me try to reduce the thickness. Anyway, so what are the different functional groups you all have learned? Tell me that. Anisha, tell me.
Ma'am, alcohol, ma'am.
Alcohol, okay. Kirtana.
Halogens, ma'am. Chlorine and bromine.
Halogens. Okay. Samanya.
Ketone, ma'am.
Ketone. Samvardhika.
Aldehyde, ma'am.
Aldehyde. Okay. Vishal, anything else remaining?
Yes, ma'am. Carboxylic acid.
Carboxylic acid.
Okay.
Yes. Carboxylic acid. Now, alcohol, all of us know alcohol, right? We all know what is alcohol, isn't it? We have a lot of different alcohols, like methanol is there, ethanol is there. The alcohol that you actually get to drink, that's also one form of alcohol. Okay. Then before the injection, the alcohol that the nurses and doctors rub on our skin, that is alcohol. Then nowadays we all use sanitizers, no? Have you felt that cold feeling after sanitizer is put on your palm? That is because of this thing called ethanol. Okay. So alcohol is alcohol. Okay. That is OH. To write. And any compound containing alcohol, we add to it the surname all. Ethan, all. Methan, all. Butanol. Okay. That is alcohol. Next is halogen. Chlorine, bromine, iodine. Alcohol, every time you use a sanitizer, you see a sanitizer, remember this. Remember ethanol, everything else will come to you in your head. Okay. All right. Next is halogen. Chlorine, bromine, iodine. Okay. Halogens are a part of the periodic table, right? Iodine. Have you all used iodine in your houses? Yes,
Yes,
no?
ma'am.
Where?
Yes, ma'am.
Where?
Salt, ma'am.
Very good. Iodized salt. Iodized salt has got two different halogens. One is chlorine, the other is iodine. Okay. So we generally Cl, Br. I is not there for you, but I'm adding I by default. Okay. So always they say ethyl chloride. Okay. So what is the suffix added? Chloride, bromide, or iodide. That is, in other words, you don't say ethan chlorine or ethan chlorogen. That sounds really funny, no? Ethan chlorogen, propan bromogen, iodogen. That sounds really funny, right? So instead, what do we say? Ethyl chloride or propyl bromide, methyl iodide. Okay. That is about halogen. So for halogen, always the surname added is halide. Okay. Then comes, can I rub this entire thing? Otherwise, it's looking very messy. Can I rub it? Next is ketone. Okay. Ketone, then aldehyde, carboxylic acid. When I'll ask what is next, you all will have to tell me. So now it is ketone. Now ketone has this functional group as C double bond O. Okay. C double bond O. The best example of ketone I can give you, you all have used ketone. Can anybody take a guess where in your house do you have ketone?
Is it nail polish removers, ma'am? Acetone.
Ah, very good. Naga polish. When I was small, we all used to call it as naga polish. The nail polish remover, it is acetone. Okay. Acetone is the best example. Now, so for ketone, the surname comes as one, O-N-E, one. O-N-E is not one over here. Okay. O-N-E is own. Not even O-W-N, own. It is O-N-E, own. All right. Then the next part. So here we have acetone. Then is propanone. Similarly, butanone. Okay. Then we have pentanone. And then we have all the other ones. Okay. Then the next part, which is the next one?
Aldehyde.
Aldehyde. Yes. Thank you so much, Kana. Aldehyde. Now, aldehyde, we use a lot of formaldehyde. Okay, there is something called as formaldehyde. That is HCHO. Okay. Formaldehyde, HCHO, has only one carbon atom. Then is acetaldehyde. We did acetone in ketone. Similarly, we are doing acetaldehyde. Sorry, what is the spelling now? Dehyde. Yeah. Acetaldehyde, that is H3CCHO. Okay. I'll just expand this. It is not to confuse you. So if I'm to expand it and write, it will come as HCCHH CH double bond O. It will be a double bond O. Always remember C double bond O. Okay. C will always form a double bond. I mean, carbon will always form a double bond with oxygen because of the valency issue. Okay, carbon will always form a double bond with oxygen. So this is the structure. That is why it is CH3 or H3C CHO. This is acid aldehyde. So what is the surname over here? You always add a aldehyde before the compound. Propaldehyde, butaldehyde, like that. Okay. Then comes the last one, that is carboxylic acid. Which is the most famous carboxylic acid you all use at home?
Acetic acid.
Acetic acid. Okay. Acetic acid. So how many carbon atoms do you think it will contain? First one we learnt is formaldehyde. From formaldehyde, you get formic acid. Then we saw acetaldehyde. So from acetaldehyde, we get acetic acid. Now you tell me, how many carbon atoms it will contain?
2.
2. Very good. 2. So here, 2 carbon atom. Okay. Now what happened in acetaldehyde? We had CHHH, then H, double bond O. Hai na? It was like this, no? Now in carboxylic acid, acetic acid, what will happen? All these things will remain the same. Only thing, instead of this H, you will get OH. Okay. So what will happen? You write it as H3C COOH. Purinjida, is this okay with you? Or did I make pongal in your head? Is it confusing? No, it's okay. All right, great. So now, just for you all to remember, we will do something. CH3, CH, double bond O. Then CH3, C, OH, double bond O. Okay. What is this? The first one? Yes, Samanya? Okay, Samanya. Yes, it is an aldehyde. Acid, aldehyde. Acid, aldehyde. And then CH3, C, double bond OH. It will be, what will it be? COOH. Anisha.
Yes, ma'am.
What will this be? The second one?
Carboxylic acid, ma'am.
Very good. That is acetic acid. Now, can any one of you guess the structure of acetone? Acetone. Anyone? You guide me, I will. H3C.
Bond C double bond.
Yes. Okay. So, now that is acetone. Okay. So, is this much clear with you? Acetic acid, acetaldehyde, acetone, ethanol. Okay. And ethyl iodide or ethyl chloride, ethyl bromide. This much everything is okay? What
Ma'am.
does this mean? Yes, yes, Anisha.
Ma'am, can you tell me the exact definition of functional group?
So functional group, exactly if you are to ask me, then I would say it is the, what do you call it as? It is the attachment, or rather some of the functional groups, you can call it as heteroatoms. Okay. The heteroatoms that get attached to the carbon compound, regardless of the length and nature of the carbon chain. Okay, I repeat, heteroatoms that get attached to the main carbon compound, irrespective of or regardless of the nature of the carbon chain, is called as a functional group. Do you want to take it in writing? Okay, 1 minute. I'll repeat it once again. The heteroatoms, H-E-T-E-R-O, heteroatoms that get attached, the heteroatoms that get attached to the carbon compounds, irrespective of, that is regardless of or irrespective of the length and nature of the carbon chain, the length and nature of the carbon chain are called functional groups. Okay. They are called functional groups. Now, there is one more thing about the functional group. Okay. The functional group don't just simply get attached to the carbon compound or to the organic compound. Okay. After getting attached to the organic compound, it changes the properties of the compound. Okay. It gives some specific property to the compound. It is like this. Okay. When we are not married, things are completely different. Most of us, in my case, though, definitely, I was very irresponsible. I would keep roaming here and there. I would keep reading books the whole day. All right. But once I got married, I got some bit of responsibility on my head. Okay. Not just me, both of us. We both have some bit of responsibilities on our head. We have to look after the house. We have to look after the family. We have to take care of the house. Right? And this is exactly what happens in a functional group. So when a functional group gets attached to the carbon compound, what happens? The property of that carbon compound gets changed. So if alcoholic group gets attached to ethane, okay, what will happen if an alcoholic group gets attached to ethane? Yashni?
Do you repeat the question again, ma'am?
What will happen when alcoholic group gets attached to ethane?
Ma'am, the property that ethane contains will combine with the alcohol properties.
Yes. And it will become ethanol.
Yes.
Right? So that it changes and it confers some specific properties to the organic compound. Alcohol ka property, some of alcohol property has got attached to ethane and some of ethane property has got modified. Okay. That is the idea of functional group. Did you understand? I think Anisha asked me, no? Did you understand what is the meaning of functional group? Okay, fine. Any other questions do you have? Anyone?
The ethane series, 147.
Can you please repeat your question? Samanya, can you just type your question? Because I'm not able to hear you properly. There's some connection problem, I think. Yes, anybody else while Samanya types the question? Anybody, anyone, a few, or else I will ask one question, okay? Okay, fine. Now, generally with up to propane or up to ethane, we have straight chains. Okay. In butane, there are two. Samanya, 1 minute. I'll just complete this question and then I'll come to you. In butane, there are two possible structures. Which are they? Which are they? There are two possible structures.
Is it branches, ma'am?
Is it cyclobutane, ma'am?
One is cyclobutane, the other is branched. Okay. So, one is, of course, there are three possible structures in case of butane or, in fact, any organic compound having more than 3 carbon atoms. In fact, even 3 or more than 3. Okay. So, first we look at butane, the straight chain 1, 2, 3, 4. Okay. That is CH3, H3C, and the rest everywhere it is H, 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 and H. The next one is branch chain. So how will you have the branch? You have 1, 2, 3, and 4. Okay. I can make a Christmas tree also if you want. So Vishal is like, hey, Christmas tree, not a Christmas tree, a Sada tree I'll draw. 3 and 4. Okay. So this looks like a tree. This is butane. Now, one more structure is there for butane, which is a square. A square or a rectangle, you can say. Okay. Now, this is cyclic. What will be the formula over here? How many hydrogen atoms will it get attached to? Everyone will get 2, 2. Correct. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So here, this is C4H8. And if you make a long straight chain of butane, it will be C4H10. That is the difference in the structural formula. Okay. When it comes to the difference in structural formula, what is going to happen? Alkane is CnH2n plus 2. Alkene is CnH2n. And alkyne is CnH2n minus 2. Okay? Plus 0 minus. Again, same thing, 1, 2, and 3. All right, this is another thing. I should have mentioned it before when we were making the structure, but conveniently I forgot at that time. Alkane, alkene, alkyne. CnH2n plus 2. No, nothing, no additions in alkene. That is 0. Alkyne is minus 2. Okay? So these are the main differences. All right. And Samanya, I think. Yeah, Samanya only asked me the question, no, about 7 carbon atoms. 7 carbon atom is septate. Okay. Ethane is 2 carbon atom. Propane 3. Butane 4. Pentane, hexane, septane, octane, nonane, decane. Okay? All right. Now, today I actually did not take up any of the questions because any important questions I did not take up intentionally because most of the students, as far as my research and my observation is concerned so far, people get confused in the functional group and saturated, unsaturated carbon atom and which carbon atom, what is the order? Methane, propane, butane, hexane, what is it? So I just sort of brushing up on those so that it becomes easier for you. Okay. Now, if you have any questions, you can WhatsApp on Vidyadan's number. You can also email on Vidyadan India, VIDYADANINDIA at gmail.com. Okay, you can email. We'll be more than happy to solve the queries. All right. Okay, I hope you all found the session interesting and fruitful. And thank you all of you for being such a good audience and being really cooperative